Okay, we're having a pretty big rain here, and I left the fan on. It's pretty hot today, so maybe it doesn't just sound as usual, but I'm going to try to speak and speak clearly so you understand everything that's happening here. And what we're going to start doing is we're going to do our K nearest neighbor. Uh, K nearest neighbor is a machine algorithm that actually tries to guess the correct data. So what we have here is we have the data iris data set. And what the iris data set is that flower petal length and width. And I really know much about flowers, but we have the data here. So whatever numbers we're given, our application should tell us what that flower petal, what species it belongs to. Versicolor, Centosa, Virginica, Centosa, Centosa, Centosa. Okay. So one of the problems here was that when we opened the original data set, we only saw a bunch of versicolors and we had to scroll down to see the rest of it. So what we wanted to do is we wanted to mix that up and make it random. So we got our data set here. We looked at our data set. Okay, see what I mean? We're just looking at all the centosas, and then if you don't scroll down, you think everything's a centosa. So let's go ahead and look at our other data here. Okay. I'm trying to find our commands instead of typing them in again because it's pretty difficult. Always got something wrong. Okay, let's look at our table. Table iris $ species. And these are our species here. We have 50 of each. That's pretty good. All right, so we looked at our table. Table. So let's look at our head. If we can find it. There it is. So let's look at our head. And here's 10 of them. As you can see, everything's looks like Sentosa over there, but it's not. There's more. And so what we want to do, one thing we want to do is we want to set seed. And what this does, it randomizes and gets everything coordinated with me. Okay, so let's run if. This is actually run R unify. That's what it means, but I like to say run if. Okay. So that just gives us some random numbers there. Gives us some random numbers. So let's turn that into a variable. HQ. Say HQ. Run if. I'm just going to call it run if. And row of iris. And then we do a HQ. And those are all of our rows. We have 100, actually it's supposed to be 150. I don't know what happened, but anyway. So let's look at another order we can do this in. Iris. Look at our iris data set. Iris. We're making a variable called iris, and we're using iris. Order. And we have HQ. No, HQ, comma. Expected symbol. Oh, comma. There we go. So now we can see that we're in a random situation here, and we can just see everything's a bit more random and mixed up. So we mixed everything up, and that's what this was doing. Okay, let's carry on. Let's go ahead and do a structure of our iris. And there's our structure of our iris. So if you want to just check all the data types and the number of rows and everything. So we have 5 rows, 150, no, we have 150 rows and 5 columns. All right, let's do a head. Well, we already did a head. Don't need to do head again. Let's do a summary. Summary of iris, comma, combine, 1, 2, 3, 4, and that should do it. Is that going to do it? Oh, yeah, that did it. Okay, let's look at this for a second, because this is important. We have our minimum number all across here and our maximum numbers down here for each column, for each attribute, as they say in database. What we're wanting to do, we don't want to keep these numbers. We want to scale these numbers from 0 to 1. So we want to turn these, we want to make all these numbers have their own number between 0 and 1. And because our k-nearest neighbor algorithm will be expecting that. And it just keeps raining, doesn't it? All right, so let me clear that. Now, we have another function. We have to make a function to normalize these numbers. So let me look for it, because I don't want to type all this in again. I made a function called normalize. This might be it. Looks like that's it. Normalize 2, because I did the first one and it really didn't do very well. So there you go with this normalize. And function x, open curly bracket, return, close, open parentheses, x minus minimum, open parentheses, x, close parentheses, divided by open parentheses, max, open parentheses, x, close parentheses, minus min, open parentheses, x, close parentheses, close parentheses, close parentheses, close curly bracket. So we got that done. Now I did a little test here, and I have to find it. I don't want to type it in again. I did a normalize 2 test. There it is. So, as I said, it turns all of our numbers into numbers between 0 and 1. So this is just a little to see if it's working or not. But the big thing is, we want to turn all of these numbers, all 150 times 5, into 4, rather. We want to turn all of those into numbers between 1 and 0. So I did that here somewhere. Did iris order? No, that's not it. Iris. Gotta look for the iris. I think this is it right here. Yeah. So I made an iris number, and I gave it this is the variable as data dot frame. This is open parentheses L apply list apply. open parentheses, iris, open square bracket, comma, C, open parentheses, columns 1, 2, 3, and 4, which is 1, 2, 3, and 4. So we don't want to turn species into a number. It's not a number anyway. It's a string, or it might be a factor. I think it's a factor in the data frame structure. It's a factor for factorizing and putting everything into, what do you call them? Categories. Yeah. Okay. So here we go. Should work. All right. Let's go to iris N. And there we go. And yes, it did. It turned all of these numbers into numbers between 0 and 1. Maybe we can get rid of some of these decimal places, but let's not do that now. I don't want to mess it up. It's looking so good. Okay, this was video part 1. In the next video, we'll complete our K nearest neighbor and show you what it really, really does.